Hello, 6th grade math students, and welcome to another exciting adventure in two-dimensional geometry. Alright, so yesterday you did a bit of a recap after our long spring break, or at least it felt long to me. And then today we're going to move on a little bit. So what have we done? We've done area of a bunch of shapes. We've done parallelograms, we've done triangles, we've done trapezoids, we've even done missing measures of parallelograms and triangles, and now, today, we're going to put them all together. We're going to mush shapes together, and what we're doing today, our lesson is the area of composite figures. So first question is, what the heck do we mean by composite? Composite, if you look at that word, it kind of looks like the word composed, or to me it kind of reminds me of that. Composed means to be made up of. So a composite figure is a figure or a shape that is made up of a bunch of other shapes. And so when you look at a composite figure, you might think that parts of it look familiar to you, but yet at the same point it's not really a shape. And so here's an example of one just to give you a visual. This is a composite figure, and it's composed of, you could probably figure it out yourself, we've got, for those of you who can't see it, we've got a triangle on the top, don't mind my bad tracing, and we've got a rectangle on the bottom. So if we wanted to find the area of this composite figure, I think some of you have already are already piecing it together in your minds, you'd find the area of this shape and of this shape, and then add them together, combine them. Another example of what a composite figure could look like is this green thing here. Kind of looks, I don't actually know what it looks like, maybe a big foot. This is the shoe, there's the ankle. Anyways, this is composed of a square or a rectangle, and on the bottom, we've got a nice little trapezoid. So to find the area of this composite figure, I'd do my rectangle, I would do my trapezoid, and then I would add them together. So you just need to remember all of your individual formulas. You're going to need to take some time to map out what shapes are there, like pull it apart, deconstruct it, and then find the separate areas and put it together. So let's do an example. Here we've got a purple figure. I don't know what it is. It's a composite figure. What's it composed of? So step one, figure out what shapes you're working with. For me, if I drew a line right here, I'd have the makings of on top a rectangle, and then on the bottom I'd have a trapezoid. So this problem's interesting because there are no measures given to you, right? It's actually drawn on a piece of graph paper. So we actually need to come up with our measures by counting the units. So for the rectangle, if I want to find the area of the rectangle, so I'm going to, the rectangle, area equals length times width. Well, what is the length? The length is 1, 2, 3, 4 units. You could count that up here as well. 1, 2, 3, 4 units. And then what's the other measure, the width? 1, 2, 3, 4, 5, 6. 6 units. Which is the same on this side. 1, 2, 3, 4, 5, 6. So 4 by 6 rectangle means it has an area of 24 square units. Okay, and let me clean up that 4. The other shape that's here on the bottom is a trapezoid. So the trapezoid, let me erase this. The trapezoid, if you need to visualize it, is right here. So you got to go back to your trapezoid formula. Trapezoid formula is the weird one. That would be area is equal to the sum of the bases, so base 1 plus base 2, multiplied by the height of the trapezoid, and then you have to half that, cut it in half. So oftentimes you'll see the formula written as 1/2 times the sum of the bases times the height. So let's come up with our measures. Base 1, 1, 2, 3, 4. It shares the side with the rectangle, so that's 4 units. The base 2, 1, 2, 3, 4, 5, 6, 7, 8. That's 8 units long. And the height, remember the height of a trapezoid is the straight distance between base 1 and base 2. So it's not this slanted side, it's actually one of these straight lines, which is 1, 2. It's 2 units between those bases. So put it all together. 1/2 multiplied by the sum of the bases, 8 plus 4, multiplied by the height. So that's 1/2 times 12 times 2. And that means we're going to have half of 24, which is 12. And then the ultimate question was, what's the area of the entire purple figure? Well, the rectangular portion is 24, the trapezoidal portion is 12, so our total area is 36 square units for this first example. Let's do another one. Here we've got a lot more going on. We have a big blue composite figure, and let's break it into shapes, shall we? I see a triangle here, so I'm going to start with that. Area of a triangle is 1/2 of the product of the base and the height. And the base is 11.2, and the height is 4.5. I don't know why my fours keep doing that. 4.5. So we've got to do some multiplication here. 11.2 times 4.5 times 1/2 gives you a final product of 25.2 units squared. You can check my math on that, but pretty sure that's for the triangle. Next, we have, I notice up here, right next to it, a rectangle. And the rectangle has the same measure of the height of the triangle, right? So it's an 8, area equals length times width. It's 8 by 4.5. Okay? And then our last shape is down here. This is a parallelogram. Parallelograms, if you remember, are simply the base multiplied by the height. So the base is 8 and the height is 6 and 7/10. So 8 times 6.7. So now we just got to do some quick multiplication, and then we'll put it all together, and what do we got? Bippity boppity, the area of the composite figure. So our rectangle at the top should be 36 square units, and this one should be 53 6/10 units, and then we're gonna take this, this, and this and combine them all together. So 25 2/10 plus 36 plus 53 6/10. Oops. I'm using a calculator. I hope that you feel free to do the same. Just reminder, you should be showing your work, taking a picture of it. So even if you're using a calculator to take care of some multiplication, show us all this stuff. And your final answer is the area of this blue composite figure is 114 8/10 square units. One quick thing to point out here. I kind of mentioned it, but you might have missed me saying it. Let's say that you were not given this 8 down here. Could you have still solved the problem? And the answer is yes, because whatever this measure is has to be the same as this measure, right? If it's if this is a parallelogram, then these two sides are equivalent. And if this is a rectangle here, then whatever this top side is, this bottom side is. So if I know that this is 8, this has to be 8, Therefore, this side is also 8. So sometimes you might think, oh, I don't have enough information to do this, but you have to be very careful about what sides and parts are equivalent to one another and use that to your advantage. One more example and then we're done. This is a little bit unique. It says find the area of the shaded region. And the shaded region here is going to be all this space here. And what's missing from this shaded region is this triangle. Think of it as if you had like a big sheet or a big rectangular, this is a bad example, but it's what just popped in my mind. You have a big rectangular piece of cookie dough, and you decided that you were going to make me a triangular shaped cookie because I like geometry. So you cut out this triangle and now it's missing. So what's left is what's around that triangle. So when you have a shaded region problem, find the area of the shaded region. The key to this, it fits into the composite lesson because you're going to be finding the area of the rectangle as if this was a full piece of cookie dough with nothing missing, a big old rectangle. And then you are going to subtract the thing that you took out. Like we took out a triangular part of the cookie dough. So we're going to subtract the area of the triangular part. Subtract means take away. So I'm going to take away this part. And what's left over is the remaining shaded region on the outsides. So again, if I ever have to find the area of a shaded region, generally the best approach is find the area of the entire shape and then take out what's missing, and then what's left over is the shaded region. So with that in mind, this is actually not too bad. The area of a rectangle is length times width, which is 6 by 5, the full big rectangle. 6 times 5 is 30. So that means this whole original rectangle with nothing missing is 30 square units in area. But we're going to take out the triangle. Triangles are half times base times height. The base of the triangle is 3. So let's make this a little clearer. The measures that we're given is that the distance across the bottom of the triangle is 3. That's the base. The base is 3. And the height from the bottom to the tippy top, straight up and down, is 3 units as well. So the height is 3, the base is 3. So 3 times 3 is 9, and half of 9 is 4.5. So the area of the triangle is 4.5, and that is the area of what's being removed. So it's 30 originally, full rectangle, minus the triangle in the middle. That's what I'm removing, and that's what's going to be left over. So that remaining area is 25.5, and that is the area of the shaded region. The parts all around the triangle that on your screen might look a little grayish or mauve. Is that a color? Maybe mauve? I don't know. Mauve. My wife says it's mauve. So yeah, there you go. Boom shakalaka. Enjoy math today. If you have questions, let us know. Show your work. You've got 7 problems to do. And yeah, if not, if you can't do it yourself, maybe message and hop on the Google Meet if you have one. Good luck. Happy Tuesday. Bye-bye.